Greetings, Earthlings! I have some more cube musings for you today. If you recall, we were talking about quarks, and a quark is something with the only physical model exists on a cube. It's quite a misnomer to call a quark a particle, and I'll tell you a bit why. First of all, let's see, what is a quark? That is a quark. It's a twist corner of a cube. Now, quark is a topological entity. It is a symmetry label, and it's mistaken to call it a particle because every object has a left and a right, for example, left and a right, but we don't call them particles. Similarly, a proton has 3 quarks, but you can't call them particles because they don't come apart. You cannot actually build a quark on a cube without cheating, like so. And you might recall, instead we can twist 3 corners, so we've created 3 quarks. These are 3 all twisted the same direction. We can twist them again. Now they're all twisted the other way. And finally, we can return them, solve position. Now you'll recall that the symmetries of quarks allow for 5-fold symmetries to emerge. If you look at this generator move, I've done it now once, twice, 3 times, 4 times, 5 times. You can build pentaquarks, and 5-fold symmetry arises. It has something to do with why we have 5 fingers, and it has something to do with the Fibonacci series too, but that one's for the reader to determine. So today I'm going to show you something called Meson, which is a quark and an anti-quark pair. You can build one of these on a cube like this. One quark on the bottom now, 3 on the top. This is a 4-quark arrangement. Okay, now we have 2 quarks. This is a Meson. I've neglected to fix the edges here because I don't want to make you wait for that. Edges can be fixed. And then we'll have 2 quarks. You see the corners are now a left twist returns this to the original place, and a right twist returns that to the original place. This makes it a quark anti-quark pair, and that makes it a Meson. Now, the first place I encountered this was in a book called Meta-Mathematical Themas by Douglas Hofstadter, and he showed us this wonderful pattern. This is what's known as a giant Meson. You see now, instead of a single corner, we've twisted this whole centerpiece. And here, twisted the centerpiece on the other side. Makes it a giant Meson. It's a beautiful pattern. Now I'm going to show you the same thing here on a mirror cube. This is a giant Meson on a mirror cube. You see, this twists back to the left, this twists back to the right, and then you have a quark anti-quark pair. You see, of course, the same symmetries with the mirror cube. You can twist 3 corners. If you look at the top here, 1, 2, 3 quarks. Twist them one more time. Now they're twisted the other way, and finally return them. The solved position. So here's your giant Meson on a mirror cube. Here's the Meson on a normal 3x3. and quarks. They're all around us. Enjoy.